Good morning, sir. Myself Ashita, and this is my presentation. The topic that I'm going to be discussing in this video is arrays. In this slide, we can see the outline of this video. So, the topics that are going to be covered in this video are introduction of arrays, types of arrays, initialization of arrays, declaration of arrays, memory representation and accessing of arrays, and arrays operations. Let's get into the third slide. First, in third slide, we can see here the introduction of arrays are given. First, you need to know what is the need of an array. I think everyone here are aware of data types. Data types is nothing but int, char and float, and I think I also know about memory. Memory is nothing but a long tape of bytes. Each element consists of 4 bytes. Some compiler takes 2 bytes, some compiler takes 4 bytes, but I am taking here 4 bytes. And to store some value, I am declaring something, that is int a equals to 5 and semicolon. Int is the data type, a is the name of the variable or an array. We didn't consider still as an array, we are taking as a variable, and the number given here is 5. So the memory that is stored in this variable a is 5. For example, only one number is stored under one variable, that is a stores only 5. In another example, if we take 6, only 6 stores in variable a. For example, in class we have 15 students and we need to collect the ages of all the 15 students. Then how can we write? Because in declaration of storing values, we are taking only one variable, one value under one variable. In this case only we will use array. What is the need of an array? To store n number of values under one variable of same data type. Example, int age, size will be 15 and semicolon. Here int is the data type. About what topic we are discussing? About the age of the students in the class, right? So age is the name of the array and 15 is the size. How many students? 15 and semicolon. In this type we will use an array. The need of an array is to store the n number of values under one variable of same data type. So the definition is given there, and the memory allocation, how much memory is allocated to this. 15 students are there, and we know that for each element 4 bytes will be allocated. So 15 into 4, that is 60. The memory allocated to this is 60, and this will be in a continuous memory location. The main point is this will be in a continuous memory location. This is about this slide, and you can refer to this, but the index starts from 0. I'll discuss in the upcoming slides. So the next slide is types of arrays. How many types of arrays are there? One dimensional arrays, two dimensional arrays, multi-dimensional arrays that can be for 3D, 4D, dynamic arrays and static arrays. So let us discuss about one-dimensional array. What is meant by one-dimensional array? An array with single row of elements can be considered as one-dimensional array. Means we have single row and n number of columns. That is known as one-dimensional array. And syntax will be data type equals to array name, array size, semicolon. As I told you, example of 15 students, you can take it that. And here we given an example in this PPT, that is int score 5. So int is the data type, score is array name, and 5 is the array size. Declaring means, as I told, to store something we need to declare. So declare, what is the syntax? That is int and array name and size. So we are declaring here. First example is of integer and the size is 5. Second example is of float and size is 10, and third example is of character of size 20. Initialization. In initialization we have two types, at compile time and at runtime. At compile time is we will declare something, after that we will initialize it with using an operator, that is equal to. In this you can see that at compile time int scores 5 is given. For example, int scores 5, that's all, semicolon. That is declaration. We are initializing it with equals to, and we will write the elements of that. For example, in scores the size is given 4, but the elements are only given, the data elements are initialized with only 3 variables, like 3 elements. What will be the fourth value? Because in size of an array it is given 4, but in elements they have given only 3. The third will be 0. For example, if it become vice versa, that is in size of the array they have given only 2, but in elements after initialization we given 3 elements, like 3, like 0, 1, 2. then it will be an error, because the size is fixed here. The in introduction of arrays I given some points, so it is also mentioned in that the size of an array will be fixed. And at runtime you can see here the same example we took, and it will be like in scores 5 we need to declare int, so I, so we are writing int I in the first one. Printf, printf means it gives output like enter array elements, we need to enter that the array elements. And then for I equals to 0, we are taking I equals to 0, and I is less than 5, I plus plus, because the number of elements are 5, we need to scanf here declares percentage d is nothing but if we took int here, so that we are taking percentage d. If we took float as a data type, we'll take percentage f. According to that it changes. We can implement the code successfully by writing the loop formula, that is for loop. And if we wrote that correctly and if you understand that correctly, you can run. Next, memory representation. Memory's representation is nothing but it consumes every element consumes suppose I took an example of 60 bytes, right? See, if the base address of the memory is 1000, the next byte will be 1004. So each element consists of 4. So it will be according to that. Accessing of memory, we can use a formula that b plus index into the size of an element. Base b means a base address, the starting address, it may be 1000, 2000 or something, and the element that we take index means index always starts from 0, 1, 2, 3 of the memory. It is also given in the second slide. The main points are given in the second slide. So index always starts from 0, 1, 2, 3 and the size of an array. This is how you can access the memory. And in the slide we can see two-dimensional arrays. What are meant by two-dimensional arrays? An array is a collection of elements of same data type stored in rows and columns. See, in one dimensional we have only one row and n number of columns. Here we'll have rows, n number of rows and n number of columns. Syntax is given there. In the syntax, the changed part is row size and column size. You need to check that. An example is int matrix 3, 4. See, always the first will be row size, always the second will be the column size. You need to check about that. And declaring is nothing but here they declared that there are 4 rows and 4 columns of data type int and 5 rows and 2 columns of data type float and char. You can check that. Here the next part is initialization. At compile time, int a 2, 3. They given 2 rows and 3 columns. Examples are 0, 0, 0, 1, 1, 1. So 2 rows will be. So we are dividing it into 2 parts. That is zeros all 1 and all the 1 parts as 1. So 2 rows can be present, right? So 0, 0, 0, 1, 1, 1. 2 rows we are initializing and 3 columns. And at runtime it is easy. In before in one dimensional, in one runtime we took I equals to 0, I less than 5 as that example. Here we need to take j also, because we have both rows and columns. There we have only one row, so we took I, but here rows and columns will be according to that you need to take. Memory representation and accessing of data is same as this. You can check the points there. Each element is continuous obviously, and each element occupies 4 bytes. Memory addresses increases by 4. As I told you, if it is 1000, it will become 1004 as it is increasing by 4. And advantages, disadvantages is normal in both the cases. Next, in this slide you can check the arrays operation. There are, according to the slide and according to my information, there are 6 types of arrays operation. Insertion means inserting an element, deletion means deleting an element, searching, finding an element, sorting, arranging the elements from ascending order to or descending order, merging, combining 2 arrays, reversing the order. Here are the code examples you need to learn. See, first we are taking a code to read a marks of 5 students and calculate the sum and average using an array. So it will become int marks 5. It is a declaring. I told you earlier, to store a value we need to declare. We have declared that in sum equals to 0. Why we took sum equals to 0? If default value is something like 1, 2 and 3, the marks, the resultant value will be changed, so that we are taking the sum equals to 0. Float is taken in average. Average is taken in float, so that the format style will be %f. And scanf and for loop you can check. Sum will be sum plus marks. see, you need to be very careful. If the statements is true, it will increment and the sum in next class will become 1. First the default will be 0 because we took the sum equals to 0, so it will be 0. If it is true, in loop it goes again and it will be incremented and the sum will be 1. So next the average equals to sum by 5. So if the average is 10, we got sum equals to 10 and the average will be 10 by 5, that is 2. And printf is nothing but we are giving the output, you can check about that. The next program here is program to print the transpose of a matrix. Okay, we are checking about the matrix. Okay, sure. Transpose is nothing but they have given here two rows and 3 columns. So after printing we should get that 3 rows and 2 columns. You can check there, we wrote for I equals to 0 and I is less than 2 and all that. Scanf also we have written. In this printf transpose of a matrix, yes, we need to transpose in a matrix, and /n is nothing but into the next slide, next line. And for I equals to I less than 3, did you check here? We are transposing the matrix, that it will become, in before slide the rows are 2, in this the rows will becoming 3. And printf /t is nothing but the tab space, and a, you need to remember that j and I, in before I and j are there, now it is become j and I. And that's it. This is my presentation and my explanation of arrays, and thank you.